Okay, let's start our tutorial then. Before starting the atomic structure, I told you we need to know why we are learning this. What is the importance of knowing the materials as engineers? Why we need to know that? Why? If you don't have any answers, that means it's not that important for us to learn materials. Why we are learning this?
Composition of materials, composition of things.
Yes, we need to know how the materials behave. We are going to select materials for different applications as engineers. So bridges, we have students from all the fields, not only civil, we have electrical, we have mechanical, civil, we all are selecting materials for our own application. So we need to know how the materials behave. To know that, we need to know the atomic configurations, and also knowing atomic configurations will let us to identify other properties. For example, how when we heat up a material, what will happen? Heating up a rubber will melt it. But if you heat up a metal, it behave differently. If you heat up maybe wood, it will be different. So materials behave differently under different conditions. So our applications are in different conditions. If you consider a bridge is outdoor application. So you can see the temperature cycles, the forces applied on the bridge. So we need to know how the material behave with different application of forces. There are different ways the forces can apply. Some are tensioning, pulling, some are pushing, some are compression, some are twisting. So with different forces, different types of forces, how this material behave, different materials behave, we need to understand that. And also, for example, and also how they behave under different temperature categories. We have summer, we have winter. Temperature is going up to 40 degrees in summer, maybe in 13 degrees in winter. So the materials, they expand and contract with the temperature differences. We should know how much it is contracting and expanding. And also we need to know how it transferring heat. If you have a metal saucepan with a metal handle, you won't be able to touch it because the heat is transferred to the handle as well. So we have to have the saucepan with the metal, but we have to have the handle in a different material like plastic to make it, or else in a different silicone material, in a way that we can touch the handle. So if we don't have materials with different properties, we won't be able to combine them and get the outcome that we need. So likewise, so to understand all of these things, how the material behave under temperature, maybe with the electricity, with other like forces, we need to know how the material behaves so that we can select the right material for a given application. Are we good? So now do you have an understanding why we are learning this?
Yes.
Yes.
Okay, that's good. Okay, before starting the atomic structure, we have an introduction part, and you have this PowerPoint in views. We have materials in our everyday life. So you can see materials, everything is made up of materials. Even the food, there are different materials, different chemicals, different vitamins. So they all made up of different types of materials. So we have different types of clothes that we use, raincoats, the winter clothes, summer clothes. So we have different clothes, and also we have electrical parts, we have telecommunication parts. So everywhere when we look around, we have materials. Even our skin is a material. We have wood, the trees, everything has our material. So we need to learn them. In different societies, back, if you look back, we have different ages. So Stone Age, the stone as a material was dominated. So everything we made with stone. And then we have Bronze Age, Iron Age. Now we have silicon, polymer, nanomaterials. Now it is very expanded area where we can we don't have to use the materials as it is in the environment. We can do changes. We can process them. We can improve properties in different ways. So even the same material, we can have two different properties by processing them in two different ways. So that is a vast area. So material engineering is one field of engineering. However, even though we are not going to that depth for all the other fields, we need to know about the basics of materials because we are responsible for selecting materials. Okay. So let's see the differences between material science and material engineering. So material science is the relationship between structures and the properties, and engineering is the material structures to produce predominated properties. So predetermined properties. That means for an application, we know what properties we need. For example, if we are making a bridge, we know this, whatever the material that we are selecting for this bridge should have these properties, this tensile properties, this compression properties, this thermal properties. So we already know the properties that we need for a particular application. So we produce materials. So we select the materials in a way that we will get the properties that we need. Material science, we study the materials as it is. Like we are starting with the materials. But in engineering, we start with the final product and we use the material to get the final properties of the final product. So why we need to study both? We are going to study about the materials. Without understanding the materials, we won't be able to do this engineering part. So we are going to study materials and then we are going to learn how to select materials for different applications. Okay. And when we consider the materials, the processing and the structure are very important. We are going to learn about the atomic structure. That means how the electrons and protons staying in an atom. So this atomic structure is important. Then also with the atoms together stay in different crystals. Some are staying like this. Some are staying like this. So likewise, the way the atoms stay in the space is different. So this structure, atomic structure and the crystal structure are important. And also the processing, whether we heat up, whether we cooling, whether we are heating up fast and slowly cooling, this processing method can change the structure. So it is important to know the structure and also know the processing methods and how these processing methods are affecting the structure, also important because these two are related to the properties that we get. So we are going to study all this throughout the course. This is just an introduction. So we have mainly three types of materials. We have metals, we have polymers and plastic, and we have ceramics. We are going to learn this. And metals are strong, ductile. They have high thermal and electrical conductivity, opaque and reflective. Don't worry about these things. I will show why these materials have these properties later on. So polymers, we have plastic, rubber, those ones. And ceramics, we have like they are brittle like ceramics. I hope you know the ceramics that we use for kitchenware and also sometimes this bathrooms. So these are the main three materials we have, and I will explain you these differences later on, considering the atomic structure and their bonding methods. Okay, so we'll come back to this. Okay, the actual topic for today is the atomic structure and interatomic bonding. So we are going to learn about what promotes the bonding. There are different types of bonding. Atoms are bonded together in different ways. We will learn it. What type of bonds are there, and also what properties are inferent from bonding. So depending on the bonding type and the atomic structure, the properties will be different. So we will discuss about that as well with this. Okay, so do you know what is this?
A periodic table.
Yes, this is a periodic table. So what is a periodic table? What do we have in this?
We have every element, what to say?
Yes,
Yes.
all the
Every
material.
yeah, every element, all the everything organized according to their characteristics, and yeah, that's it.
Okay, yes. So all the materials that we have found so far are in the periodic table. So we call it a periodic table because all the materials that we have found so far are arranged in a way depending on the atomic number. So atomic number is the number of protons in the nucleus. So when you consider an atom, you have a nucleus. In the nucleus, you have positive charges and the neutrons. Neutrons, they don't have a charge, but they have a mass. So the neutrons and the protons, or the positively charged ones we call the protons, they stay in the nucleus. And then the electrons will orbit around the nucleus. So we have electrons, protons, and neutrons in an atom. So here, depending on the number of protons, we have arranged this. So where we can find the number of protons, we call that the atomic number. So hydrogen has 1 proton, atomic number is 1. Helium 2, 3, 4, 5, 6, 7, 8, 9, 10. Likewise, you can see this is arranged according to the atomic number. That means according to the number of protons that we have. Does that make sense?
Yes.
And we have rows and columns. So these columns, if you look at the columns, this columns shows you, before that I will tell you the number of rows. So these rows, first start with rows. Rows shows you how many energy levels are there, how many shells are there. So hydrogen has just 1 shell around the nucleus. So 1 electron will stay in that 1 shell. If you look at lithium, lithium has 2 shells. Potassium has 3 shells. Rubium has 4 shells. Likewise, 1, 2, 3, 4, 5. This row number tells you how many shells are there around the nucleus. Make sense?
Yeah.
Columns tells you how many electrons are there at the outermost shell. So outermost shell, that is the last shell of the atom, has how many electrons? So this one has just 1 electrons. All of these ones have just 1 electrons at the outermost shell. Second column has just 2 electrons at the outermost shell. So that's how the periodic table has made. You may already know this from your chemistry high school, but I would like to start from the beginning so that it will be easier for us to understand the rest of the things. Are we okay with the periodic table?
So the row, did you say the rows or the numbers of the box, like the number of the element?
Number here, but whatever the number that at the top, that will give you the atomic number. That means your number of protons in the nucleus.
Number of protons in the nucleus.
Number of protons in the nucleus, yes.
Not how many shells does it have?
No, how many shells are given by this row number. Row 1, row 2, row 3, row 4. How many shells?
Okay, that's the row.
Yes.
Okay. And
And
so second row would tell you that's two shells.
yes, so 2 shells, 3
Okay.
shells, 4
Yep.
shells, 5 shells.
Uh,
And the column number says how many electrons are in the outermost shell.
how many electrons in the outermost shell?
Yes.
Okay. So that would be those numbers 1, 2, 3, 4. Like on top of titanium, there's 4. That's four there.
Yes. Yes.
Okay.
So when I tell you about the electron configurations in, like, today we will learn it. So for the time being, we have a D block and those ones, but don't worry about it. Just for the time being, this numbers here tells you, the column tells you how many electrons are in the outermost shell. Make sense?
Oh, yeah.
Okay.
Yeah.
And in an atom, we have protons and electrons in the same number. If we have 1 proton, then we have 1 electron as well, because that they should be balanced. They should be 0 in total charge, 1 plus and 1 minus. So even though we say these are the number of protons, it is equals to the number of electrons as well. Make sense? Okay, now let's move on. So this one's actually I told you. So atom consists of electrons, which is negatively charged, protons, which are positively charged, and neutrons, which are 0, 0. And if you consider the weight of electrons is very less compared to the weight of protons and neutrons. Okay, you don't need to remember these numbers, just you need to understand that protons and neutrons are heavier and they are staying at the middle, and electrons are not that heavy, which are orbiting around the nucleus. And we discuss about the atomic number. Atomic number is the number of protons in the nucleus, and it is equals to the number of electrons, because positives and negatives are equal. I already told you that. And there is another one called atomic mass unit. So it is a unit, like, we have grams, we have centimeters. Likewise, we are defining a unit here called atomic mass unit, and it is 1/12 of mass of a carbon. So mass of a carbon, 1/12 mass of a carbon, we call that amount we call 1 atomic mass unit. Make sense? And we have another term called atomic weight. Atomic weight is weight of 1 moles of atom. Mole is a number. Dozen is 12, am I right? Dozen of bread means 12 breads. Mole means again a number like 12. Mole is equals to 6.022 times 10 to the 22. So this is just a number like dozen is for 12. Mole is this number. Does that make sense?
Oh, yeah.
You
Yeah.
don't record this lecture on Zoom?
Yeah, I am recording this one, and I'm going to put this in the Panapto, but I need to check.
Not Zoom, miss?
I am recording in Zoom. I can download it and put it in Panapto.
Please, yeah, so I can download it.
Yeah. And the other thing is, we call something isotope. So what do we mean by isotope? So that means we can have 2 types of carbon, for example. In both the carbon, we have 12 electrons and 12 protons. But we can have different number of neutrons, which are 0. So this can be 12, but this can have a 13. So these both are carbon, but they are very similar. The only difference here is the number of neutrons. So these two types of carbon, we call that isotope. So atoms having the same number of protons and new electrons, but different number of neutrons, we call them isotopes. Does that make sense?
Yes.
Okay, so these are just definitions. I hope you all understand the definitions. We are going to use these names and you should have that understanding. So atomic weight is the weight of 1 mole. You can find it in your periodic table. So at the top of any symbol, you can have the atomic number, which is the number of protons or number of electrons. But at the bottom of this symbol, you can find the atomic weight. That means grams per mole. How many grams is a mole of this atom? So you can find it at the bottom here. And also for every element, we have a symbol. So hydrogen, we don't write it as hydrogen. We use the symbol H. So this is the symbol, but you can see the name underneath as well. So underneath the symbol, you see the name and also atomic weight. So atomic weight is the weight of 1 mole. Okay, I hope the terminologies are fine. Now, when we consider the electronic structure, we have two structures. One is the Bohr atomic structure. This is what we are going to learn. Bohr atomic structure means we consider the new protons and neutrons are staying in the nucleus, and the electrons are orbiting around the nucleus. So electrons revolve around atomic nucleus in discrete orbitals. Energy of electrons are quantized. So that kind of a structure we call the Bohr atomic model, and this is what we are going to use to learn about the materials. And also the atoms, they have wave mechanical model. They are sometimes act as a wave. So electrons have wave-like and particulate properties. Two of the wave-like characteristics are electrons are in orbitals defined by probability. Each orbital or discrete energy level is determined by quantum number. So when we consider the wave mechanical model, we consider about this quantum physics. You may have heard of that as well. So they have like energy packets. They jump from one place to another place. I will explain these parts later on as well. So just remember that we have this model where the electrons are randomly orbits around this nucleus, and also the wave-like structure. Okay, now to learn more about different elements, different materials, we need to know how these electrons are staying around the nucleus. So I told you, when you look at the periodic table, these rows tells you how many shells are there. So that shells, we give a name quantum number n, shell 1, 2 shell, second shell, third shell, fourth shell. Likewise, we give a quantum number depending on the shell number. So if you consider any element in the first row here, they just have this one shell. But if you consider any element in the second row here, they have both shell 1 and shell 2, quantum number 1 and quantum number 2. If you consider anything in the third shell, you have 1, 2, 3, all 3 shells. First shell, second shell, and third shell. And also these shells have subshells. So if you consider, first shell around the nucleus, this one has just one subshell that we call the subshell S. We need to remember these names, subshells, SPDF. So, but if you consider the second shell, it has two subshells. First one is the S, second one is the P. So these are just names given to that. If I write it in a proper way, first shell has just one subshell, S. Second shell can have S and P both. Third shell can have S subshells, P subshell, and D subshell, SPD. The next one can have SPDF. Next one also have SPDF. Rest of all these ones have SPDF. Makes sense. Are you guys okay with this? I want you to understand
Yeah.
these subshells and the shells. Are we good?
Yes.
Okay. Now the other thing that you need to remember is this S can hold 2 electrons. P subshell can hold 6 electrons, and D can hold 10 electrons, and F can hold 14 electrons. So you need to know this number of electrons in different subshells. S can hold 2, maximum 2. You don't have to have 2, but S can keep 2 electrons. P can keep 6, D can keep 10, F can keep 14. Is that clear?
Oh, yeah.
Okay. And also when they are staying, when they stay, when you consider S has just two electrons will stay like this. 2 electrons. And P can hold 3 electrons. So how they fill is 1, 2, 3, then starting like this 4, 5, 6. So that's how this 6 is filling. I will show further later on. And D can hold 10. So that means we have 5 space here. So first, second, third, fourth, fifth, sixth, seventh, eighth, 9, 10. They are not filling like, 1, 2, 3, 4 like that. They are filling in this order. First, they are going this way, and then again start from here. I will take an example and will explain you this, okay? So for the time being, just remember this SPDF and also how many electrons can be staying in subshells. That will be enough. Okay. Any question? We need to know this to understand the differences between different elements.
We'll
How
get this
they-
in the quiz.
Yes, you can get this kind of questions in the quiz.
Are they multiple choice?
In the
Or
multiple choice, I think in the quiz, I need to check. I think mostly they are
written?
written questions, yes.
Do we get theoretical?
I will let you know, okay? I
Okay,
will let you know when I meet you next week.
all right.
We will have a look on the past quizzes and we'll make sure, confirm.
We get past the sample.
I can give you a past one, yes.
Thank you very
As a
much. Yes.
sample, yes.
I appreciate it. Thank you.
Okay, so this is what I was telling you. Okay, now let's see. Okay, let's take one by one. Hydrogen. If you look at the periodic table, hydrogen is, atomic number of hydrogen is 1. That means it has only 1 electron and 1 proton and neutrons. Am I right?
Yeah.
So that means where this 1 electron around the nucleus, where it is staying. So we said we have S in the first shell, S and P in the second shell, S, P and D in the next one, S, P, D, F in the next one, like that. So where is that one electron stays?
S.
In the S. So this is where the electron stays. So S electron stays like this. So if you want to write the electron configuration for hydrogen, you say 1s1. So this one means it just have one. This is the first shell. This is the subshell S. And how many electrons? So when you say 1s1, this is the shell number, this is the subshell name, and this is the number of electrons in that subshell. So if you want to write the electron configuration for hydrogen, you write it as 1s1. Is that clear?
Yes, ma'am.
If you have helium, where you have 2 electrons, 2 atomic number, how do you write it?
1s and 2 on the
Yes,
upper side.
1s and 2 at the top, like this. Then lithium has 3 electrons in the periodic table. How do you write it?
1s2 and 2s1.
Yes, 1s2 and 2s1. So in the first shell, in the S subshells, it has 2 electrons, and the remaining third electron will go to the second shell, and that will hold one electron in the subshell S. Is that make sense?
So that's 2s1.
2s1, yes. So this is
Okay.
for lithium is 1s2, 2s1. So how do you know how many electrons altogether, whether you did it correctly? When you add these numbers, it should be 3 because the atomic number is 3 for lithium. Is it clear? Is that clear?
Yes, ma'am.
Okay, now let's do we have some examples. I want you to do this by yourself. Carbon has 6. So we are not going to look at this. We are going to do it here. Carbon has 6. I want you to do for the carbon. How do you do for the carbon? 6. You don't need to remember these numbers 6 and all. They will be given to you. The periodic table is given to you. So 6.
1s2, 2s2, 2p2.
How do you know 6 is there? 2 plus 2 plus 2 is 6. Is that make sense?
Yes, ma'am.
Okay. So now let's see how we have to follow a pattern here. Sometimes these shells will stay in this way. So you can see the first shell is the S shell. Then you have 2S, 2P. This is your second shell, and this is your first shell. And the third shell, you can have S, P, D. But do you see this one? 4S is in between. What that means? That means this shells means their energy levels. So this is the lowest energy level. So you can see the energy levels. This 4s, energy of 4s is in between the P and D of the third shell. So 4s is staying here in between. How do we know this? So we can find it out just by having this pattern. So electrons are dropping in this way. So first we drop electrons like this. Then the next electrons like this. Then like this, like this, like this. So this is how the electrons will be dropped. So we can have this kind of you can draw this in your piece of paper and you can use it. For example, let's take, we have something with 23 electrons. We don't know the element, but we know number of electrons. We are going to write the electron configuration for this. So when we are writing, so we have 23 electrons, we can drop 2 in the S. Am I right? S can hold, one S can hold 2 electrons. Is that right?
Yes, ma'am.
Then we have remaining, how many remaining electrons are there? 21, am I right? This 21, so we are dropping 2, 21 is remaining. So 2 can be dropped in 2s2. Am I right?
Yes,
Then
ma'am.
we have 19. So that 19, P can have 6, isn't it?
Yes.
So 2p6. So 19 minus 6 will be 13, isn't it? So that out of that 13, this 3s can take 2, isn't it? So this will become 11. Make sense? Do you understand what I am doing?
Yes, ma'am.
So out of this 11, P can again hold 6. So that will be P6. This is for the third P. So this is the first, second, and this is the third. So 3p6. And then before going to 3D, you can see S is there. See, S is there along the path. So before writing the 3D, we have to write 4s2. Then we have only 4 in the other one, which is 3D, 3D4. Is that clear or not?
Yes, ma'am. Yeah.
At the beginning, you may get confused, but when you do few questions, you will be fine. So do you understand the pattern that I have followed? How do we know whether we have 23 electrons altogether, whether we have done all 23? You can add these things and you can count the numbers. So if we have 23 altogether, do we have 23? If we have 23, that means this is right. Why this 4s came before this 4s? See this 4s? Because when we dropping electrons along the path, before this 3D, 4s is coming, isn't it? So 4s, so you can see the energy level is staying between these two. So we have to fill this one before moving to the next. This is the main part of whole lecture today. So if you understood this, that is the main part. Anyone have any question? We do a lot of questions in the tutorial, okay? Don't worry, don't get scared if you didn't understand. Please let me know so that I can explain again. Is there anyone who didn't understand this? No. Okay.
So Miss, why did the 3P, the 3D come before the 4S? Sorry, why did 4S come before 3D?
Before 3D, 4s is there.
Why is that, Miss?
Because the energy, this shell staying like this, they are spacing because of the energies. So this energy of this one is in between these two. Energy state
is that how it's structured?
Sorry, what was that?
Is it just how that's structured?
Yes, we just follow that structure. It is the way it is the way. So it's like, you know, it is the way of the energy levels. That's how the people who did the research found it. Like, you know,
Okay.
yeah, like, you know, leaves are green, so they are green like that. This energy 4s is energy of the 4s, energy level of the 4s is staying in between 3p and 3d. That's how the research researchers found it.
Correct. Thank you, Miss.
Okay. So I would like you to do few. So you don't look at this one. Maybe can you do this too for me, please? Argon has 18 electrons and krypton has 36 electrons. Let's do the argon. I will give you time. What you need to do, you just need to write this. First shell has just S. Second one has S and P. Third one has SPD. Fourth one has SPDF. Rest of the things SPDF. That's all. Only 4 type of subshells. Okay. I'll give you a few minutes. And you go in this way, okay? This is your pattern. Diagonally. And also you need to know S can have 2, P can have 6, D can have 10, F can have 14. So this is all you need to know.
Ma'am, only argon's one. Only argon.
Yes, argon and krypton. First, let's do the argon and see how you go. Then I want you to do the krypton as well because it has 36. First, let's do the argon.
Yes. It's 1s2, 2s2, 2p6, 3s2, and 3p6.
Okay, yes, that's right. I will wait for the others as well, okay? I'll give a bit more time for others to do as well. You can do 30 krypton. If you finish argon, you can do the krypton. Are we done?
So if we finished, we can do krypton.
Krypton, if you finish, you can do krypton, but if you want my help to do krypton, I can do that.
Okay.
You can try by yourself first, and I will help you if you're stuck. And how about the argon? Have you done for the argon, all of you?
Yeah, I got it.
How about others? We have 23 students, so I would like to know from all of you. You can put in the chat, or else you can raise your hand. There are so many options here. Are we good? See, this chemistry part is at the very beginning, okay? After that, you don't have this chemistry. Okay, that's good. So you don't have the chemistry is only few weeks, first few weeks, and then we move to other engineering properties, and it'll be not the chemistry. But to understand the engineering properties, you need to know the chemistry as well. So that's why we are learning it at the beginning. You are not going to do chemistry. So let me check with you all. with the argon. So is there anyone who wants me to do the argon electron configuration of argon? Are you all okay with that? Or do you want me to do it? If at least one of you want me to do it, I can do it. Otherwise, if all of you are okay, we'll move to the krypton. I think you all are okay with the argon. How about the krypton? Did you get?
I have done the krypton one.
Okay. Did you get
So
this?
yeah, I got 1s2, 2s2, 2p6,
Yeah.
3s2,
Yeah.
3p6, 4s2,
Yes.
3d10, and 4p6.
Okay. So your S is, you can keep the S here, or if you want to, you can arrange it in a way that it has 1, 2, 3, 4 in that way. Okay. It's not necessary, but if you want to, you can bring the 4s together, keep the 3s together, and 2s together, and 1 together. Okay. It's up to you. If you don't do it, that doesn't mean you are losing marks, so it's wrong. So you can rearrange it, or else you can leave it. Are we good?
Yeah.
Okay, what we call that here, they say stable. What do we mean by stable? Stable. Stable means your outermost shell is completed. So we know SP, SPD. So you can see this one. Do you see that? This shells, the P is complete, S is complete at the outermost shell. So that is more stable. So here S is complete and 4S is complete, 4P is complete. Yes, it's the D is not complete, but still this is stable than having incomplete. So if a subshell is completed, if it has S is completed with 2 at the very end, outermost shell, and if the P is completed with 6, then we call that one is more stable. Otherwise, it is like to getting electrons or giving electrons to something else and become stable. So when you look at the periodic table, I told you this column shows you how many electrons are at the outermost shell. So hydrogen has 1 electron at the outermost shell. Barium has 2 electrons at the outermost shell. But if you look at the boron has 3 electrons, carbon 4 electrons. This one is the D block. That means, do you remember the D is filling after the S of the next shell. So this one is D block, where you have D as well. So carbon has 3 electrons, so 4 electrons at the outermost shell. Nitrogen has 5, oxygen has 6, fluorine has 7, and neon has 8 electrons. So this one, if you look at the outermost shell, it is fully filled. So here we call them inert gases. They don't react with anything. They don't react with anything. They are inert gases because their electrons are filled at the outermost shell. But if you look at this fluorine, chlorine, boron, iodine, this row, they have 7 electrons at the outermost shell. And if they can get 1 electron more, they will become stable. So they would like to get an electron from something. So they are very attracting electrons. But if you look at this first column here, if they give electron to something else, they will become fully filled. Outermost shell is fully filled. For example, let's take sodium. Sodium has 10 electrons. But if it gives 1 electrons out, it will become, sodium has 11 electrons. If it gives 1 electrons out, it will become 10 electrons. That means it's like this one, neon. So they are like to give electrons and become stable. these columns, when you go further here, they like to gain electrons and become stable. Do you understand what I mean?
Yes, ma'am.
Okay. Okay, now let's see the other thing. So you guys are good with writing electron configuration, and we are going to do more questions in the tutorial class. And if you didn't understand, you can ask me next week Tuesday during our face-to-face session. Okay, now it is very important to know how many electrons are in the outermost shell, because they are the electrons which is which will react with other elements. So we call them valence electrons. So wherever you say valence electrons, we are talking about the electrons in the outermost shell, not the outermost subshell. We are talking about the outermost shell, all the subshells together. Okay, so here you can see outermost shell, how many valence electrons. If someone asks you how many valence electrons are in carbon, the carbon has 2 shells, because if you look at the periodic table, it is in the second row. So that means 2 shells are there. At the outermost shell, the second shell, it has only 4 electrons. So carbon valence electrons in the carbon is 4. Are you okay with that? Finding valence electrons. You just look at the number of electrons at the outermost shell. Okay. So valence electrons are the electrons who are contributing to any reactions, any bond. This is what I told you. So how, when filling electrons, they fill in this order. See, it's for example, if we take P has 3 spaces. So if we have just one in the P, it will stay like this. If you have 2 electrons in the P subshells, they will stay like this. 3 electrons will be staying like this. 4 electrons will be staying like this. 5 and 6. So half-filled subshells also has some stability. So if you consider these two, if you consider these two, for example, so this one has 4 electrons in P, and this one has 3 electrons in P. So this one we call more stable compared to the above one, previous one. Why more stable? Because subshell is halfly filled. When the subshells are halfly filled, also it is stable than having less or more halfly filled subshells. So that we need to know that later on. We are going to use this information later on. So we need to know that. I hope you understand. Fully filled is stable, fully stable, but half filled also comparatively stable than the other non-half filled ones. Make sense?
Yes, ma'am.
Okay, so now electron configuration part is over. Now, not like we will do questions in the tutorial class. Now let's see few other things in the periodic table. When you look at the periodic table, I told you the number of rows tells you how many shells are there around the nucleus. Am I right? So when you go down, what do you think? What will happen to the atomic radius? They are becoming bigger or smaller? This one has 1 shell. The next one has 2 shells. The third one has 3 shells. Next one has 4 shells. So what is happening to the atomic radius?
Bigger?
They're
Increases. Am I right?
yes.
Yes. When you go in to the left, from the left to the right, what is happening to the atomic radius?
They're becoming smaller.
Why they are becoming smaller? Because they have, if you consider this row here, this one here, you have only 3 shells. 3 shells. For all of them has 3 shells. Why they are becoming smaller?
Because the electrons of the last shells are gonna increase the attraction to the proton, because that's just decreases the radius.
Yes, that's right. So when you go from left to right, number of protons and number of electrons are increasing. When you have protons, when you consider protons and electrons, they are positives and negatives. So they attract to each other. So when you have more protons and more electrons, this attraction force is bigger. So because of that, when you go from left to right, your atomic radius is decreasing. Do you agree with that?
Yes, ma'am.
So atomic radius decreases from left to right, atomic radius increases from top to bottom. This is very important because when you have larger atomic radius, then that will be more, those elements like can easily emit an electron. But if you have the atomic radius very smaller, then that means it is attracted, electrons are attracted towards the nucleus, so it's hard to get an electron out of the atom. So when the atomic radius is high, easily electrons can go out, but when the atomic radius is less, it's not that easy. So when even in the left, from the left to right, even though you have the same number of shells, these ones are more, they like to, when you go towards the right, they like to attract electrons rather than giving an electron out. I already told you that part before as well. So these ones like to give an electron out, but these ones like to receive an electron because of that. So we call this side are electropositive elements, readily give up electrons to become a positive ion. So these ones would like to become a positively charged ion, cation or positively charged ion. These ones here towards the right, they would like to attract an electron and becoming a negatively charged ion and get stable. And the other thing of the periodic table is knowing metals, nonmetals, and intermediates. So from here, you can see this line is where you can find metals and nonmetals. Everything this side is non-metals and everything here is metals except hydrogen. Everything towards the left is metal. So this is our line. You can see this L kind of a line. That is where differentiate the metals and non-metals. The ones which is close to this line, they have metal behaviors and also non-metal behaviors. We call them semiconductors as well if you do electrical subject. So these ones, barium, carbon, silicon, germanium, arsenium, selenium, they have metal and non-metal properties both. But the other ones towards the left, they are metals, and towards the right, they are non-metals, except the hydrogen here. Are we good?
Yes, ma'am.
Okay. Then there is another term called electronegativity. Electronegativity is tendency to attract an electron. How easily an electron can be attracted. So we have these ones are more electronegative because they are easily can become stable just by taking few electrons. So we say electronegativity is high towards the right. So electronegativity is increasing when you consider from left to right, electronegativity is increasing. That electronegativity means how easily an electron can be attracted to that atom. So it ranges from 0.7 to 4. And So it is the tendency to acquire an electron. So that's already you know. Okay, so we have covered that part. Now we have covered how what information that we can find from the periodic table, and also atomic information means atomic number, the shell number, or else the column rows, and also electronegativity, the atomic radius, metals and non-metals. So we have an idea of the periodic table now. And also, depending on the atomic number, that means depending on the number of electrons, we also know how to write the electron configuration. There are few exemptions in the electron configuration for copper and chromium. I will tell you that in the tutorial class after you get familiarized, after you do few questions in the tutorial class. Otherwise, we know how to write the electron configuration. We know how to understand the periodic table. And now we are going to move to different types of bonds. Before that, do you have any question? Do we have any question? No questions? Okay, all right. So there are three types of bonds. Ionic bonds, metallic bonds, and covalent bonds. They are the primary bonds. And we have secondary bonds as well. They are weaker bonds. We learn them later on. So let's see what do we mean. Metallic bonds are the bonds in the metals as a cloud. So for example, if you consider magnesium, neutrons will stay like this and all the electrons stays like a cloud. So this we call the metallic bond. So the electrons are very easily movable. That's why we can conduct electricity through metals. So they we call the metallic bonds. Ionic bonds mean when we have a metal and a non-metal, and if we exchange electrons, we give electrons, and one is giving electrons and the other one is accepting electrons. That kind of a bond we call it's an ionic bond. For example, magnesium and oxygen. If you look at this in the periodic table, magnesium is where is magnesium? Here, and it is a metal. Oxygen is this side, which is a non-metal. So magnesium has 2 electrons at the outermost shell, and oxygen has 6 electrons at the outermost shell. So if magnesium can give the 2 electrons at the outermost shell, magnesium will become stable, and oxygen would like to take 2 electrons from someone and would like to become stable and fill the outermost shell. So what these two are doing is, if you look at the, if you write the configuration, electron configuration of magnesium, that will be this. So we have 1s2, 2s2, 2p6, and 3s2. So this, it has 2 valence electrons, and that one, magnesium would like to give that one away. So magnesium would like to give that one away and will become magnesium 2 plus. That means this one will be given away, and this has only this. And this is equal to the electron configuration of neon. Why is that? See, this magnesium, if it gives 2 electrons, that means it will become neon. So neon is a inert gas, stable. So magnesium 2 plus will be stable, has a stable configuration than the magnesium. And what is happening with the oxygen? So oxygen has, if you write the electron configuration of oxygen, it is 1s2, 2s2, and 2p4. So when this p is not fully filled, these 2 electrons which is released by the magnesium, will taken by the oxygen, then the oxygen 2 negative. Why the 2 negative? It has 2 additional electrons. Magnesium gave 2 electrons away, so it has positively charged. But oxygen is taking 2 electrons, so it is negatively charged, and the electron configuration would be like this. So both magnesium ion and the oxygen ion now has inert gas configuration, electron configuration. So this ionic bond is made up of metal and a non-metal. When the electron negativity is higher, it is happening better. So if you consider something at the very end and something from this end, that will be easily can happen. So for example, sodium chloride. Sodium is this end and chlorine is this end. So sodium would like to give 1 electron out and chlorine would like to take 1 electron in. So sodium chloride will make easily. They stay very nicely because sodium is at this end and the chlorine is at the other end. Are we good? So this is again an ionic bond. Why we call it ionic bond? They give away electrons and one is accepting. One is giving, one is accepting. So they're not sharing electrons, they are giving away electrons and accepting electrons. That kind of a bond, we call it a ionic bond. Are we good with ionic bonds? Any question? Okay, so okay, let's move on if you don't have any questions. Do you guys need a break? Are we good? We have few more slides, but if you want a break, I can give you a break. Do you need a break?
Yeah, miss, how long?
Sorry, what's that?
How long?
Just 10 minutes maximum. 10 minutes, we can't take 10 minutes, maybe 5 minutes, please.
5 minutes.
Yes, please come back at 9, okay?
Okay.
Are we all back?
Yeah.
Okay, that's good. Okay, we have few more slides. Okay, I'm not going to keep you long. We'll finish this topic and yeah, with few more slides. Okay, so we know about the ionic bonds. So it's occur between positive and negative ions. We already discussed about it, and requires electron transfer. So it is transferring electrons. If we have large difference in the electronegativity, that means one end and the other end of the periodic table, then it is much easier to form ionic bonds, like sodium chloride. Sodium is at this end and the chlorine is at the other end. So sodium is sodium is giving electrons to chlorine, and chlorine will become negatively charged and sodium will become positively charged. So that is a ionic bond. And positively charged ion, we call that a cation, and negatively charged ion, we call it an anion. Okay, now we have a question in the tutorial for this graph. I will explain you it further in the tutorial class. So when we have positives and negatives, what will happen is positive will positive and negative will attract, and positive they are not attracting, they are opposite, so they like to stay away from each other. So we have repulsive forces and also we have attractive forces, because positive will be repulsive and positive negative will attractive. So when you consider two atoms or two ions together, sodium and chlorine, for example, they can't come closer, like, this radius between the atoms R is defined by the attraction forces and repulsive forces. So you have electrons and protons in both the ions. So depending on attraction force and the repulsive force, this R will get fixed depending on, in a way that it will make the energy minimized. So you can see this repulsive energy in green and attractive energy in blue. So if you add both together, this is the total energy in red. So mostly this R will be staying in a way it minimizes the energy. So this is the minimum energy point. So that this particular R, which gives you the minimum energy, that we call the R, stable R, which is R naught. So in some questions in the tutorial, we are going to find this minimum R using this equation. So this total energy, we can find that total energy is equals to attractive energy and also the repulsive energy. So this attractive energy and repulsive energy, if you consider, one is positive, one is negative, because the direction is opposite. So you have two energies. When you add them together, you can find the total energy. When this total energy gets minimum, then that corresponding R value, we call that the more stable, the distance between the two atoms, which is R naught. We are going to find it in the tutorial class. Okay, so ionic bonds examples are ceramics. So you can see sodium chloride, magnesium oxide, calcium fluoride, cesium chloride. So they all ionic bonds. Okay, now the second type of bond is a covalent bonds. So covalent bonds are not transferring electrons, instead they are sharing electrons. For example, methane, CH4. So carbon has 4 electrons at the outermost shell. So if carbon can get another 4 electrons, carbon will become stable by having 8 electrons at the outermost shell, because 2 electrons at S and 6 electrons at P, then this will become fully filled. So 8 is needed to become fully filled. So what hydrogen can do is, hydrogen has one electron at the outermost shell. So if hydrogen can get one electron from carbon, then hydrogen has two electrons. Hydrogen just has S. So S only need two electrons to get stable. So what this hydrogen and carbon doing is they are sharing electrons together. Now these red dots are hydrogen electrons, blue dots are carbon electrons. So you can see around the carbon you have 8 electrons. So carbon is stable by sharing electrons. Around hydrogen you have 2 electrons. So that hydrogen also stable. So this kind of a bond we call the covalent bond. So to become covalent bonds, you need to have similar electronegativity, close electronegativity, and bonds determined by valence, how many S and P they are, like, carbon has 2 and H has 1. And this is how they form by sharing electrons. Are we good with the covalent bonds? Do you understand what is covalent bond?
Yes.
Okay.
Ma'am, I had a question.
Yeah.
The equation we saw at the ionic bonds slide, are we gonna learn more about that later?
Yes, this one you mean?
This one. Yeah, this one.
Yes, we have a question. We have a question in the tutorial. To find the R naught, what we need to do is we need to find the minimum energy. So you can try the questions if you want to. So, if you take the first derivative of this one and if you make that to 0, you know that in maths, right? You can find a minimum or a maximum of a function by taking the derivative.
Yeah.
If you haven't done that in maths, don't worry, I will teach you in the tutorial class.
Okay, ma'am.
Okay, so we are doing a question with this one. Don't worry if you didn't understand this energy graph. We will do a question with numbers. It is easy with numbers than having letters. Okay, now the next thing is it's very hard to find out whether it is a covalent, ionic, what the bond is. So we have something called ionic character, percentage ionic character. It shows us the percentage. If the percentage ionic character is high, that means it is going towards the ionic type bond. So again, we are going to do a question with this in the tutorial. So the equation for percentage ionic character is this. You don't need to remember equations. Equations will be given to you. So E is you have the exponent in the calculator, that E. XA and XB are Pauling electronegativities. So if you know the electronegativities of two elements, you can put them in the equation and find out how much is the electronegative percentage ionic character. If it is high, that means it is mostly the bond type is ionic bond. So magnesium oxide, we said that it is ionic bond because magnesium is at the left hand side and the oxygen is in the right hand side, and they are a metal and a non-metal. Electronegativity difference is very high because they are in two ends of the periodic table. And if you look at the electronegativity of magnesium is 1.2, electronegativity of oxygen is 3.5. These are found values. We know these values. These are given values, known values, and you can put these two values to here. A or B can be either magnesium or oxygen, it doesn't matter. So 1.2 minus 3.5 to the square divided by 4. If you put this one in the equation, in the calculator, you get this. It doesn't matter whether you have 3.5 first or 1.2 because you are taking the squared. So it doesn't matter which one comes first. So you can see the ionic percentage ionic character is high. So this one is, as we have explained before, this one is an ionic bond. Make sense? So we have a chart to find out. So you can see different bonds here. So these ones here are metallic. These ones are covalent. These ones here are ionic, and these ones are semi-metals, semi-metallic bonds. So this is another like graph where we can find out the most dominant bond types in elements. Are we good? Any
Ma'am,
question?
do we have to remember this graph?
No, you don't have to remember this one. Mostly in your questions, we may ask you to, we will give you these numbers and the equation, and we may ask you to find the percentage ionic character. But like, you don't need to remember this, but you can use this in the industry or wherever you are working in future to find out when you consider, for example, NCl3, whether it is covalent or whether it is. So you can look at this one and you can find out what are the dominant bonds that you have in between those two elements. So CH3 is, sorry, CH4 is covalent. So this NP is covalent. So likewise, you may need this to, depending on what kind of a job you do, you may use it, but in the exams, we are not going to ask you to remember this. If we ask a question, we will be giving this to you and ask questions. All good?
Yes.
Okay. Okay. So the primary bonds are metallic, ionic, and covalent, and we can have secondary bonds. They are not strong. They can be hydrogen bonds and van der Waals attractions. They are very weak, but time to time they also can be there. So they are happening because of the dipoles. So you have positives and negatives in an atom. So positives can be, you can't exactly say positives are staying like this, negative is evenly distributed. So your negative ones can be in one side and they are randomly moving. So this is not always staying like this, but because of the random movement, because of this like movements, they are having dipoles. So when we have dipoles, they have a weak attractions or repulsions. So this one will be called the secondary bonds. Are we good?
Yeah.
Okay. Okay, I told you this one before as well. So bond length is very important. So that is R. And depending on the bond length, you can see how the energy is changing. I told you this minimum energy corresponding, the bond length for the minimum energy is important for us because that is the most stable way, stable distance that the two elements can have. And also, if you look at the melting temperature, when you have smaller, when you look at this one, melting temperature is large if the minimum energy is large. So you can see this is one ionic bond between two elements, and this is another ionic bond between another two elements. So you can see, if you look at the melting temperature is high when you have high minimum energy. Melting temperature is less when you have less minimum energy. These ones are important, not now. We are discussing about the thermal properties later on. So I will remind you when we go to that topic. So thermal properties, we will be looking at how the materials expand, how much of heat transfer. So those kind of things again related to the atomic arrangement, atomic structure and the crystal structure. However, we will look at these ones later as well when we do that topic. And also thermal expansions again. some material, thermal expansion coefficient. Don't worry about these things. We are learning this in one topic, 1 week.